So I want to start up just by a short story. So sometimes I teach programming. It's pretty rare. But there was this time I was teaching programming, and it was a very beginner person. They were missing a semicolon in a code. They didn't know what was wrong. So please, can you help me? And I was sitting there. Of course, I immediately saw the semicolon was missing. But we spent like 5 minutes trying to help this person like find it themselves. Other people were eventually also needing help, so I had to like point out, okay, it's there. It's been a really long time on doing that. And then they asked, so what do you do when you have a problem that you don't know how to solve? And in my mind, I was concocting this elaborate way of saying that I don't have such problem without sounding like an asshole. And then they quite brilliantly said, but I guess there's always somebody better than you. I suppose there is, but sort of my experience is that once you become really good, the people who are better than you are only really better than you in one very specific area because they spend a lot of time in that specific area. And it's quite possible, eventually quite easy, to find areas where there's nobody who has spent more time in this particular area. And this is such a case because nobody before me, I think, has done probability in TensorFlow.js. Even the people writing TensorFlow.js probably haven't. And so this talk is really about like how do you as like a fairly advanced developer, I would think of myself at least, survive what really turned into sort of a nightmare situation for me here, where really at the edge of what is possible. Right. So just sort of to give you a short introduction here to TensorFlow, Tensor is a multi-dimensional array. So here we have a 2D array, many rows. Each row is an observation, and then 2 columns that we can put on an XY coordinate system. And input here is then that object. And our task here is to sort of given XY coordinates, predict what color it should be, or associate that with color. Here, color represents a class of flower. You can do some fancy math there that we're not really going to care about. And this fancy math here turns out some nonsense that's completely useless. And you can also get told how bad your nonsense is arbitrary number 1.46. And finally, what's really the interesting part is you can make your nonsense better by using optimization. So in this case, optimization algorithm called gradient descent that you're also not going to learn about. A lot of things you will not learn about here. But gradient descent uses something called gradient, that uses something called differentiation. If you're familiar with any kind of math, you might have like nervous strips of cold sweat running down your back now. But you shouldn't really, because TensorFlow provides you an opportunity or a method for computing these gradients using T of the grads. It just does all the hard math for you. And then finally we have this bottom part here that is the optimization algorithm, and the only thing you really need to know about is this T of the tidy here at the bottom. So this cleans up memory. The reason is that all these operations here are running on the GPU. In order to do that, you of course need to have some memory on the GPU, but the thing is that JavaScript doesn't really have any kind of awareness of what's going on the GPU. So you need to like clean up memory manually. That's not something you'll be used to as a JavaScript developer, but it's necessary in this case, and it can be quite tricky, but T of the tidy sort of makes it easy by just removing all the unused memory once the function ends. Yes?
I'm a little confused. What's the output? You mentioned the colors. Is the colors the output?
The background here is the output. So that's the prediction we're currently making just for every single combination of x, y. And the observations, the dots there, is sort of where we want to get at. So we're going to use them to learn this algorithm here. So that's really what you're seeing now. So now we run the code, and you see each iteration going here. So this is a browser presentation here. You see Chrome, it's a URL here, localhost. So this is running in my browser right now. And well, it'll learn this. Some call this AI. I think that might be a bit of exaggeration, but it's essentially the fundamental principles in the kind of artificial intelligence you see. And well, that's what I do for work. So just to summarize, it's operations on these multi-dimensional arrays, tensors, parallelizes on the GPU using WebGL for JavaScript in the browser. And you can do these kind of mathematical optimizations using TF.grad, and memory is free with TF.tidy. Okay, no other questions. Right. So a bit more about me is, yeah, I'm a freelancer doing mathematical models like this one, but a bit more advanced. When I don't get paid for that, I'm a researcher in machine learning. Just finished a publication with DTU a few months ago. And as Kevin said, I'm also a Node.js contributor or collaborator, I think it's called, meaning I can force push to the master repository, and I have done that. And also authored, co-authored, or been involved in any of these modules here. So I can pretty much guarantee that all of you are running my code somehow. This is pretty cool. I mean, they use this in NASA spacesuits and stuff like that. Else was the job interviews. Right, so this was one of the tasks I got. Make this question answering system. Does the president think that a Brexit might not go through? And then you get an answer. And these answers here, they come from transcripts from the White House briefings. It's very boring. I read a lot of them. And you get some fairly political answer by the press secretary. Sometimes Obama in this case, that was during his presidency. And the challenge here is that this search algorithm here has to run completely in a browser due to privacy issues. So you just download one big file, and then you do the entire search algorithm on the browser. I'm not sure that has ever been done before, but you can let me know. So herein sort of lies the programmer's nightmare, my nightmare, that you're gonna laugh up because of my pain, and then you'll also learn something from that, I hope. Already know how I want to solve this. I want to use Latent Dirichlet allocation. If somebody here is French, they can tell me how to pronounce that middle one. It looks very scary. I looked at this too long, so it's not that scary anymore, but this is the only really scary thing. Like when I see this, I have the cold sweat. This is called the digamma function. Sorry, I think we should put like a warning, like advanced math. Okay? Yeah, would be a good idea. So this involves some differentiation, integration. The really difficult thing here is this infinite. As infinite things goes, they're quite difficult to compute, not to say impossible. It's hard to count on to infinity on a computer. So how do people use this? Well, they use approximations. They don't compute it exactly. You might think this could be simplified to something if you're familiar with like advanced level math, but it cannot. It's just this. All right. So if this was in Python, there's also a TensorFlow version for Python, then you could just call this digamma function that contains an approximation and does all the hard things for you. That does not exist in the JavaScript version. Okay? So now you feel the problems are piling up. My problems, okay, you don't need to worry. Just laugh at me. All right, so your first sort of idea would be to just hack a solution, right? This is, I think, a good approach. Validates that it's hard. You learn about the challenges, and you also sort of get a baseline solution where you sort of identify what is the problems that you would need to overcome in a better solution, quote unquote better. So if you go on npm, there is indeed somebody who has made a digamma approximation function here. I don't know if it's any good. Experience tell me it's not that good, but I mean, sorry to the author, I didn't test. This is indeed what I did for this demo project here I was doing. So there's one really big thing to be aware of. There's this await tensor the data. So your data is going to be on the GPU. That's where the calculus is happening, or not calculus, but the operations, because that's a bit faster. But this JavaScript module here, it runs on the CPU, of course, like normal JavaScript. It is normal JavaScript. So you need to transfer this data from the GPU to the CPU, and you just do that with await tensor the data. And then after that, you use the npm module, and then you put it back on the GPU with tf the tensor. And that's sort of fine, and it does work. Here's the two problems. So when you do this kind of a wait here, tf the tidy, as talked about before, no longer works. It only works as long as all the operations happens in one synchronous go. And so I can pretty much guarantee in what I was paid to do, that's probably a memory leak. Yeah, sorry about that. And then also this tf the grad also doesn't work because we're sort of jumping out of the TensorFlow land and then jumping back into TensorFlow land. So this TensorFlow grad algorithm, it doesn't have any idea what's going on. Right.
Also,
yeah,
you're doing the D grammar on the CPU instead of on the GPU, right?
yes, very good. You want to
you're jumping from the GPU to do the very heavy computation in the CPU and then put it back to the GPU.
yes. So I'm not going to repeat that. That's a perfect description of point number 4. What you might not be so aware is that also the memory transfer from GPU to CPU can also take time. If it's like a phone, it usually doesn't take that much time because it's actually the same thing, the same chip. But if it's like a really fancy computer that has an external graphic card, then it can take quite some time. Right. So at this point, I think it's a good idea to sort of think about a solution or make like a draft of this. So TensorFlow does actually support you writing custom operations, but you have to implement everything in JavaScript and then also in WebGL both. And you will then do that, and that's the forward function here. And compile abstracting a lot, so compile for either JavaScript or WebGL, depending on what is supported. And then this backward thing here just tells tf the grad how things are tied together. And so we actually end up using another very scary function called the polygamma function. And so what I sort of would recommend once you feel like I'm really like to the throat in problems here is sort of, okay, let's go back to the fundamentals, this digamma function here, and try and learn about this. So just sort of try and implement something simple, understand what the challenges is. And in this particular case here, a good way to learn about the fundamentals is really to look on like scholar.google.com and look up scary academic research, right? And so here's an example of scary academic research. It's called approximation for the psi function. I don't know why the resolution is suddenly so bad, but well, the psi function is also the digamma function, just what the Greek letter is called. This is how they do it. It looks kind of weird, this math, if you can see this, because this was like hacked together on a typewriter 50 years ago. And then it went into the American Congressional Library, and then somebody like 30 years later scanned it in, and now you can find it like this. I think it's quite funny. Because of this also, so this function here, you don't need to concern yourself with this, but it depends on a lot of constants, like there's a lot of them. Okay, all of these constants I would need to type in perfect precision. If I type any of them wrong, like a few values might be okay. In fact, many values might be okay, but eventually there's gonna be some issue. So it uses these constants to approximate it. Doesn't matter. Also, this function here only takes values between 1/2 and 3. So this guy here, he published this very difficult research and only managed to find one that works between 1/2 and 3. This function here takes input between 0 and infinite, or however big numbers double can contain. Right, so obviously there's some work left to do here. And so from experience, I know that implementing a function like this can take between like 3 days to 2 weeks. Also know, at least I'm gonna use this polygamma function. And from also experience, I know that I'm probably gonna use like all of these functions actually. Like I'm probably use like 80% of those. Yeah, if not more. And all of these functions here, they exist in the Python version. They do not exist in the JavaScript version, okay? So running it in the browser is still a long way away. So what I really want is, I want all of these functions in the JavaScript version, but how do I get there, right? And this sort of leads me to point number 3 here, which is like, of course, look at what other languages are doing. So this can be quite scary if you're not familiar with those languages. A good thing to do, I think, is just like as quickly as possible, cut as much off that you don't need. In this particular case, I can just look at what is the dependencies or library like TensorFlow or SciPy uses. And then I will find that they use some particular library that is like dedicated to this purpose. And that way I can really like cut away a lot of complexity in a language that I'm not that familiar with. Or that I'm familiar with Python. Right, and yeah, so read the scary source code. So then you will find Cypress. This is the official homepage for Cypress. I think it's beautiful, no? How many here thinks it's beautiful? Nobody, okay. I don't know how Professor Steven will feel about that, but I think it's beautiful. You know, this I'm pretty sure it's made from some Apache plugin or something like that. It's surprisingly, it still gets updates. The last one was in 2014. It does have the diagram function that we need and a lot of other functions. So this is excellent. And so this sort of leads me to point number 4 here, is really to respect the wisdom of the old. Like sometimes I just have some problem here and then I end up like deep in some obscure C code of a Linux kernel that was like published 10 years ago, or I don't know. Yeah, so like read the scary source code, don't be limited by bad documentation. Like if you're living in sort of the modern world and you love the React documentation, that's sort of fine, but if you at some point have like a challenge that you're not really sure how to do, but there might be this thing, but it has like really bad documentation, it's a good thing to like already have practiced a bit of bad documentation reading skill. Right, and have the hardware ready for the cold sweat. You guys do that? The hardware? No, okay. Never mind. Right, so this is a scary source code. There's some documentation here. Besides the math, I guess it's not that scary. Then there's the code here. So at this point here, I think it's a good thing to sort of familiarize yourself with what is the capabilities of WebGL, and then compare that to the C code here. I will try and explain it in a way that where you don't need to learn C. So there's this thing here called goto. Gotos are not allowed in WebGL. How many here knows gotos? Kevin, we live in a different age now. Okay, so this was once like very popular, and then it was like completely like abandoned because it's really bad programming practice. It just allows you to jump from one arbitrary point to another arbitrary point in the code, and obviously you can imagine that has a lot of side effects, but it's really fun. And Steven here thinks it's fun too because he wrote this before such thoughts were made that it's a bad thing. Right. Sorry, I should say Professor Steven, right? He's an American professor. Right, so it also has a while loop. You might think that's okay. While loops are not allowed in WebGL, okay? And so now you can really, you need to call somebody because I'm like drowning in problems. So we need to transpile C to WebGL. There is no tools available for this. It might not even be possible because while loops and gotos are not that easy to like do something else then. And this is especially because GPUs are not like CPUs. They only like support the very small feature set. They do a lot of cheating in different ways in order to run many different kernels, many different cores at the same time. And that's how they get to like 10,000 cores or whatever they are now. I think like the NVIDIA card V100 that costs like 130,000 core. It has like 115,000 cores or something like that. But I mean, you also pay a bit there. Right, you can ask me more about that after the talk if you want to know about the GPU limitations and how they're designed. I work on like supercomputers, so I know scary much about that. Right, so this sort of brings me to point number 5 here is like make a list of challenges, and then in particular when you sort of decide, okay, I want to prototype some kind of solution, especially like focus on just one major challenge. So in this case, there was different functions that I needed to implement, not just the diagamma function, like, and then go through the code here for me. In this case, try and find the one that is the least problematic, but still hit like one big problem. Because I see a lot of beginner developers, and not just beginner developers, but even like really senior developers, they get very tempted by solving fairly easy problems because it's like mental cognitive ease is called. Like it doesn't like stress them so much, and they still get to like do their fancy optimization. Oh, am I gonna do a while loop here? You know, things that's not important. And so they're scared, like even really senior developers, they're scared by hard problems. So they also want like to be distracted. But like I just want to recommend, like if you should take one thing from this talk here is when you're faced like a really big challenge, then try not like get distracted by the easy problems. Try and just work around them in the beginning and then go back to them later. All right, so let's make this list of challenges here. I just picked out a few. So only fixed length arrays. You don't need to learn C here, but COEF stands for coefficients. It's an array here of length n. This is not allowed, okay? You cannot have that. Only fixed length arrays. So you need to like put in that coefficients always have 6 elements. It does not always have 6 elements, so this is quite a big problem. And then while loops, as I said, not allowed. You can only have like fixed length for loops where you put in like a constant. This has to always go to 10. You cannot even put that it has to go to n. No recursive functions. So this function here calling itself, no. You cannot have gotos. You cannot have implicit conversions. So this negative here. That needs to be a Boolean, but it's actually an integer. No. This works in C, not WebGL. And finally, there's no like the same concept of memory on a CPU does not really exist on a GPU. So I mean, you don't need to concern yourself with this term here, pointers. But the result here is you cannot really return multiple values in the same way. And actually, for JavaScript, this is also a bit of a challenge because that works quite differently. And I think in total there was like something like 20 problems I had here. And so what I again just want to recommend is like try and focus on one big problem. For example, can I survive that we cannot do recursive functions? Right? Because okay, you can rewrite a recursive function into a while loop or for loop or something like this, but remember that you can only have fixed length loops. So like this might actually be impossible, and somebody might be able to disprove me here, but I would actually stipulate that WebGL is not Turing complete. Yeah, if you don't know what that means, that's okay. So, you know, now the entire room here is filled with cold water, and then I end up surviving all these challenges, and I do publish this module here, published it yesterday. TFGS special, call it, and it has all of these functions here. I wrote like tons of algorithms from transpiling from C to WebGL. and also to JavaScript. And well, that's what I want. But I mean, don't care about this. You're not going to use it for anything, right? At least I don't think so. So really, this is the important part, right? As I said, try and familiarize yourself with the basics. You might think this doesn't really apply to you, but just say you write React like every single day, right? That's perfectly fine, and that's going to get you through like 99.9% of all problems. But once you hit that like 0.1% problems, I mean, you might be able to hire somebody better, and that's, I think, an okay strategy. But if you want to be really good, you need to like think about the fundamentals. So how do I create an element using nothing but JavaScript and DOM, like document.createElement? Right, and take uncomfortable steps like investigate a library in a language you never read anything in before. It's an uncomfortable step, but you can learn a lot. And perhaps the most important part is like focus on the hard problems and don't get distracted by easy problems. It's really surprising like how many like developers that has like really senior positions still wants to like focus on the easy problems. And then finally, I think this is particularly like as you go from beginner to intermediate, at least as I recall it, like don't be scared. Like instead, be happy that you're gonna learn something. I think that's really important. So in this case, you know, I mean, yeah, it's very scary. There's like probably like 10 things here people have never done before, but you know, I'm really looking forward to actually learning something here. All right, so yeah, this is it, it's called. Thank you.